Yeah, welcome back, friends. Today we are going to discuss about alcohols as one among the groups of organic compounds which we need to learn in advanced level. So, alcohols together with the other hydroxyl compound as phenols will be discussed in this subtopic of organic chemistry. So, what are the alcohols? Don't worry, I will not be writing everything, but you will get these notes for free. So, what are the alcohols or hydroxyl compounds? Hydroxyl compounds are organic compounds which have a hydroxyl group and their functional group. So, one characteristics of hydroxyl compound is that they have hydroxyl group and their functional group. Now, remember we said a functional group is the group of elements where chemical reaction or in the reactive site of a compound. When we are talking the hydroxyl compound and the compounds which have a hydroxyl group or the functional group, that means reactions taking place in the alcohol, they take place in this hydroxyl group or they take place in these elements. So if hydroxyl group is attached at aliphatic carbon chain, the compound is also described as the alcohol. So if this one is attached to aliphatic chain, compound is described as the alcohol. But if it is attached to aromatic ring, then the compound is described as phenol. So phenol functional group yake, yani reactive group ni hydroxyl, lakini inakuwa ni benzene. Phenol inakuwa ni benzene, alafu kwenye ile benzene we have hydroxyl attached on the benzene ring. So if hydroxyl is attached on the benzene, it forms what we call as phenol. It forms phenol. So tunachokisema ni kwamba alcohol and phenol have the same property which are similar and some property which are different. So some of the properties of alcohols and phenol, they are similar because all of them they have a functional group which is hydroxyl. But some of the properties they are different simply because phenol had the benzene ring, but alcohol they don't have benzene ring. So presence of benzene ring in phenol lead to the different in properties as compared with the alcohol. So the difference between alcohol and the phenol are due to the difference nature of the side group. Kwamba alcohol zinakuwa zina side group which is the aliphatic hydrocarbon, but phenol they have a functional group which is aromatic ring. So difference in the function, difference in the attached group. Attached group inapelekea difference kati ya hizi two groups of compounds. So hence, at the end of this topic, you should be able to give the similarities and differences between phenol and alcohol. You should be able to give the similarities between phenol and alcohol. All of these, they are hydroxyl compounds, but they have some of the similarities and differences. So for the sake of today's session, we'll start by discussing alcohols. So alcohols are hydroxyl compounds which have a hydroxyl group attached to the aliphatic hydrocarbon chain. Hydroxyl group ambayo inakuwa hivi attached to aliphatic hydrocarbon chain. So if we have a hydroxyl group attached to aliphatic hydrocarbon chain, it forms what we call as alcohol. Kwa hiyo alcohol is simply represented by ROH. That's how alcohol inakuwa represented, ROH. So the general formula of alcohol, it is CnH2n plus 1, then hydroxyl. So one of the hydrogen in alkane, it is taken by hydroxyl group. One of the hydrogen in alkane is taken by hydroxyl group. That's what we call the alcohol, and the functional group of alcohol appears as CnH2n plus 1. But we call this, can be abbreviated as R, which is alkyl group. So we are just writing alcohol as ROH. So we have like different examples of alcohol. Unaweza kuweka tu CH3OH. This is methanol. Then CH3CH2OH, ethanol, and different other categories of alcohol, as how we shall see in the notes. But what important for you to know here is that tunakuwa tuna alkyl group iliyokuwa attached with the hydroxyl group. That's what we are calling at the alcohol. That's what we are calling at the alcohol. So from there, what we can discuss is about the classification of alcohol. The classification of alcohol. So alcohol, they are classified depending on the number of alkyl group attached on the carbon with the hydroxyl group. So for example, having CH3, then OH, CH3, CH2, then OH. That is to say, CH3, C, H, OH. The carbon with the hydroxyl group has only one alkyl group attached to it. But for example, if we have CH3, C, then you have CH3, OH, then you have H here. Carbon with the hydroxyl group has two alkyl group. Yani hapo haitegemei alkyl group na ukubwa gani, lakini ziko mbili. But also if you have CH3, C, CH3, CH3, then OH. Alkyl group moja, mbili, tatu. Kwa hiyo hii hapa inatupeleka kwenye groups of alcohols. This one, we call this the primal alcohol. Primal alcohol tunaandika kama moja na kaziro. This is secondary alcohol, and this is tertiary alcohol. So we have primary, secondary, and tertiary, depending on the number of alkyl group attached in the carbon carrying the hydroxyl group. So if the number of alkyl group is greater, that means the E itakuwa ni primary, secondary, then hapa ni tertiary. Hiyo ndio classification. So alcohol are classified into 3 classes based on the number of alkyl group attached in the carbon carrying the hydroxyl group. That means based on the carbon carrying the functional group. So we have primary carbons, primary alcohols. These are alcohol compounds which have only one alkyl group attached to the carbon atom containing the hydroxyl group. Kwa hiyo hii carbon atom inaitwa alpha carbon, au hapa inaitwa alpha carbon, na hapa inaitwa alpha carbon. So kwenye hizi primary carbon, there is only one alkyl group attached to the alpha carbon. This is primary alcohol, secondary alcohol, and then tertiary alcohol. From there, manake tutakuwa tuna secondary alcohol, ambayo secondary alcohol, these are alcohol compounds which have 2 alkyl groups attached in the alpha carbon. Kwa manake secondary alcohol kwa kama. Lakini tertiary alcohol, as sometimes in the secondary alcohol, because we need the R, then C, then R, and then from there we'll have hydroxyl H. Sometimes you may meet with a compound like having a benzene ring here, and then after having a benzene ring, here we have C, then CH3, hydrogen, hydroxyl. This is also an alcohol because the hydrogen is attached on the side chain, not on the benzene ring. So it is not phenol kwa sababu phenol hydroxyl lazima iattach kwenye benzene ring. This is not phenol, this is just an alcohol, and all of these act as one alkyl group, and this is another alkyl group. These are the secondary alcohol. Then tertiary alcohol, these are alcohol compound which have 3 alkyl group attached in the alpha carbon. So tertiary alcohol we have R, then we have C, we have R, we have C, we have R dash, we have C, we have R, then you have hydroxyl. Kwa hiyo hizo ndo zinakuwa kama tertiary, alcohol. From there, going to discuss kuhusu IUPAC nomenclature of alcohol. How do we name alcohols? Tunazipaje majina alcohol mbalimbali, IUPAC nomenclature. So alcohol are named just like alkanes, except kwanza kwenye alkane kama tuko na name methane, hii huku mwishoni E is replaced by or. So methane yenye carbon moja kwenye alcohol CH3OH is named as methane huku tuna name methano, so tunatoa hii tuna replace with OL, and then the position of hydroxyl group is indicated by the number of carbon atoms carrying it by the root name and the primary suffix O. So between the root name, let's say tuna CH3, CH2, tuna CH, then hydroxyl, CH3. Hii hapa tayari na carbon nyingi, so it's butano. Lakini pamoja na kuwa na carbon nyingi, yani kuwa butano, hii hydroxyl iattach kwenye carbon ya kwanza, so itakuwa kama butan hyphen, unaweka hydroxyl kwa 1 2, butan hyphen 1, I mean butan hyphen 2 or butan 2 or inakuwa jina hii compound. Manake ni compound, then tunaweka na position of attachment of hydroxyl group, inakuwa ni butan 2 or position of attachment of the hydroxyl group. And if the compound containing more than one hydroxyl group, then indicate the number by representing di, tri, tetra before the suffix or. Hiyo inaeleweka kwa sababu tumeshaifanya kwenye many groups of organic compounds. Tumefanya kwenye many groups of organic compounds. Lakini from there, number the carbon atoms so as to give the carbon atoms containing the hydroxyl group the lowest possible number or lowest a set of log anti-log. Kwa hiyo kwa mfano tumefanya kwenye compound nyingi hiyo. Kwa mfano ukiwa na CH3 CH hydroxyl CH3. This is straight 1 2 3 is propan, then hydroxyl is located in carbon number 2, so it is propan 1 or manake it is propan 2 or manake hydroxyl imejiattach kwenye carbon ya pili, propan 2 or. Lakini kwa alcohol kama huyo hapo ambayo tulisema huyu naye ni alcohol. This is also an alcohol. This is also an alcohol ambaye hii hapa jina yote inaweza kupata kama benzyl. Benzyl alcohol. Au mwingine anaita kama ni 1-phenyl methanol. Yaani hapa inaitwa methanol, ile hichi hapa ni phenyl. So mwingine anaweza kanena 1-phenyl methanol. Au ni benzyl alcohol. Kwa mfano compound kama hiyo hapo ukipewa uname compound kama hiyo hapo, anake ni cyclohexanol. Hex cyclohexanol. Hex cyclohexanol. From there we have other compounds here. We have other compounds, but they are easier. So since they are easier, you can just pass through them. When you get the notes, you can just pass through them. But we have some of the compounds which have two functional groups, as we have seen here. For example, we have CH3, CH, that one C, hydroxyl, CH3. So 1, 2, 3, 1, 2, 3, 4, 1, 2. So tuanzia kumoja mbili hydroxyl hapo na mbili yetu na huyo. Kwa hiyo itakuwa ni butane, hii itakuwa ni buta 2 and then 2 O. Buta 2 and 2 O. Hivyo ndivyo ambavyo jina la hiyo compound inakuwa hapa. Hakuna not buta kwa sababu buta tunaongeza a kama tukawa tuna diene au diol, labda butane 2 or au in case za kule organic compound nyingine labda buta 3 triene ndio tuko natumia buta. Kwa hivyo ndivyo ambavyo nomenclature of alcohol inakuwa, ndivyo ambavyo nomenclature of alcohol inakuwa. From there tuna isomerism in alcohol. Isomerism kwenye alcohol tuna positional isomer, skeletal isomer pamoja na functional isomer. Positional, skeletal pamoja na functional. Positional zinatokana na change position of hydroxy. So kwa mfano kama ukiweka CH3, CH2 hydroxy, huyu hapa tukimchange kuja hapa anakuwa positional isomer. Au tukichange CH3 CH2 CH hydroxy CH3. This is positional isomer. Tumechange position of a functional group. Lakini kama tukichange skeleton CH3 CH CH3 CH2, hapa functional group ambako kule kwenye carbon ya kwanza, lakini tumechange skeleton. This is a skeletal isomer. Skeletal isomer tunabadilisha mpangilio wa carbon. Positional isomer tunabadilisha functional group ilipokaa tunaipeleka sehemu nyingine. So hiyo ndio difference kati ya skeletal pamoja na positional isomers. Lakini pia tuna functional isomer ambazo tunapanda change functional group. So we can get from here CH3, CH2 or CH2, CH3. This is what we call the methoxymethane. I mean for this is ethoxethane. Manake hii hapa inaitwa kama ethox, then hiyo inakuwa ni ethane. So ethoxethane ndipo ambapo tuna name hizo. So for example this one is ethoxethane, na pia ziko nyingine kama tunaanza na group mdogo, tunamname pamoja na oxygen. Alafu group mwingine tunamname kama parent chain. Hizi tutaenda kuzidiscuss huko mbele kwenye esters. Tutaenda kudiscuss huko mbele. Lakini kiujumla ni kwamba we have three types of isomerism. This is functional. Tumechange functional group kutoka kwenye alcohol kwenda kwenye ester. Tumechange kutoka alcohol kwenda kwenye ester kwa kupata kitu kama hicho. Tumechange a functional group kutoka kwenye alcohol kwenda kwenye functional group ambayo ni nyingine. So from there we can discuss about the physical properties of alcohol. Physical properties of alcohol. So on the physical properties of alcohol, first is the solubility in water. Alcohol, they are soluble in water due to formation of hydrogen bond. So alcohol are soluble in water. This is due to the hydroxyl group in alcohol, which is able to form hydrogen bond with water molecule. Now we have hydrogen bonding between alcohol and the water. If you understood our general chemistry about the concept of hydrogen bonding, I hope this one will not be tough or will not be difficult for you to understand. So the interaction of alcohol and water through hydrogen bond makes alcohol to be soluble in water. Alcohol with a small hydrocarbon chain are very soluble in water. That is because a hydrocarbon chain is non-polar. As the length of hydrocarbon chain increases, the solubility of alcohol in water decreases. The reason why solubility decreases as the length of hydrocarbon chain increases, it is because the hydrocarbon chain is the non-polar. So the reason why solubility decreases as the length of hydrocarbon increases is because the size of alkyl group increases, the polarity of the molecule decreases. Polarity of the molecule decreases. Alcohol compounds containing aromatic ring are less soluble in water compared to those without aromatic ring. Kwa hiyo alcohol ambazo zinakuwa zina aromatic ring zinakuwa less soluble. Note, non-blanched alcohol are more soluble in water than the corresponding blanched alcohol. So we are discussing all of these because sometimes you are given the question to arrange the compounds in order for increasing solubility. Unatakiwa unajua kwamba the length of hydrocarbon chain increases, the solubility decreases. But also, if the alcohol contain the aromatic ring, its solubility decreases with corresponding to another alcohol having the same number of carbon, but it does not contain aromatic ring. But also you need to understand that the branched alcohol, they are less soluble as compared to the straight alcohol. That is because of the surface area for the formation of hydrogen bonds. The second is about the boiling point and the melting point. A boiling point and the melting point of alcohol increases with increase in relative molecular mass. As with the alkanes, the branched alcohol isomer have low boiling point than the straight chain isomer because branching reduces the surface area of molecule and hence reduce the intermolecular force of attraction between two molecules. So in order to understand well many concepts in organic chemistry, you need to be well, or you need to understand the concepts in general chemistry. So if you understand concept in general chemistry, it will be easier for you to understand many concepts in organic chemistry. So the order of boiling point of isomeric alcohols follows the following order. The boiling point of primary alcohol will be greater than the boiling point of secondary, and the secondary will be greater than the boiling point of tertiary. And the reason behind is because the tertiary alcohol, they have more branching as compared to the secondary and the primary. And the secondary alcohol, they have more branching as compared to the primary. So branching tend to cause a decrease in the boiling point as compared to the corresponding compounds having no branching at all. So alcohol molecule are polar and they can form a hydrogen bond between themselves. For this reason, their boiling point is higher than those of corresponding alkanes having the same number of carbon, alkenes and alkyne, which are non-polar molecules. So the polarity of alcohol molecule is due to the high polarization of the hydroxyl group. The polarity of alcohol molecule decreases with increase in size of alcohol molecule due to the increase of size of alkyl group, which is the non-polar group. Hiyo tumesha discuss. Generally, the boiling point of alcohol is associated with the hydrogen bond and the van der Waals forces, which require large amount of heat to overcome. So here are the questions which can be asked is to be given a number of alcohol, and then you are asked to arrange them in order of increasing or in order of decreasing boiling point, in order of increasing or decreasing boiling point. So let's end up here. Remember to do a recap: introduction to hydroxyl compound, introduction to alcohol, categories of alcohol, a IUPAC nomenclature of alcohol, and finally the physical properties of alcohol. In the next session, we will discuss about the laboratory preparation of alcohol. We shall see how can we prepare alcohol in the laboratory by different reactions. Remember, the reaction we studied in part of alkane, alkene, alkyne, and even those we studied in benzene, all of them, they are still applicable. So we still are being applying the equation in the preparation of alcohol. Thank you everybody, and let me wish you nice studies.